Ladies and gentlemen, welcome to the garden. We've got to turn this fridge pressure down a little bit because we've got a little bit too much capacity for the PID control. Just while I'm making a mess of getting started on this video, just in case you didn't know, in a lot of the world there are regulations on who can actually do anything with fridges if it involves accessing the gas in any way. So whether you're just connecting a gauge or something that seems really simple, you're probably not allowed to do that without a special qualification of some sort or training where you are. Do not do this. Entertainment only. I'm sorry I have to say this, but of course I do. Nothing to do with me if you get it wrong. And also at some point later, because I'm an expert, I did say evaporator pressure or evaporating pressure, can't remember which, and I actually meant crankcase pressure or compressor suction pressure, as that is what we were actually adjusting. So we weren't changing the evap pressure specifically, we're changing the crank pressure or the crankcase pressure, which is what the compressor suction sees, which therefore reduces the capacity. What we've got here is we're going to check what conditions we're at using the pressure readings we're now getting. And if I look on this high pressure gauge, the high side is about 160 psi gauge, and you should never use gauge, ever, unless you're looking at an actual gauge. So if I put 160, oh crap, spelled it wrong, 160 into the app, I can see it's condensing at 31-ish degrees. And that puts us somewhere around here, and I happen to want mid-20s capacity-ish. So on the low stage, I'm evaporating about 60 psi. Okay, it's not quite true because it's not quite straight into the compressor, but it's close enough for this purpose. But I'm on the compressor side of the restrictor. So my evaporator is 6, which is about 3.2. And if I look at here, that means I'm evaporating somewhere here, and we're at 30. So I'm in this region here, which is sort of 30. Now we really need to be down here a little bit. We need to be sort of close to this, probably about -10, -5. Because that's our load on the chamber, and that's what we need to match it to. So if I said -5 or so then, so if I put -5, that gives me 40 psig. So what I'm now going to do is close up this restrictor or the valve, which is a crank regulator, which is what the compressor sees. And as I close this valve, the low side gauge is going to drop, which means that we're going to be evaporating at a cooler temperature. And not only that, we're also going to end up with better power consumption, i.e. lower power consumption, which is generally going to be good. So we're backing the valve off now, and it's not making any difference until it engages. There'll be a certain point when the pressure will, or it's where it is naturally now, but when the valve clicks in and starts to restrict the flow, then that's when we'll see the pressure start to drop. There you go, it looks like we've got movement on the low side now. And you can see we're dropping down. The high stage pressure has gone up a bit, but I'm not particularly worried about that because it's about 6 o'clock here in the UK, and it's only going to get colder overnight. That's not really going to be a problem for me. You can see now that the lower side gauge is still dropping slightly. And that's going to put us back towards 40 psi, which is what we got from the data sheet. That looks about somewhere like alright. So, if I look at where we are now, we've got our 40 psi, which we said was about -5, so we're going to be around here, which is sort of low mid-20s. It's exactly where we want it to be. Anyway, that's the relation between the pressure that you read and the temperature that you read, and work out how to actually apply that to what pressures you need in the system using a gauge and some way to adjust it. And that's all she wrote.